So very good morning. So I just want to complete this example as I promised you. So today we will see around 4 examples related to part 1 chapter 2. Okay, so I think this part we couldn't cover that day. Okay, so we will see based on whatever we have studied earlier in the lecture. We have seen a lot of parameter involving fluid and also its properties. Okay, so based on whatever we have studied, we need to check at this question what are the information that they give. So based on that, we can choose the appropriate formulas in order to calculate. Okay, we will see example one. In a fluid, the velocity measured at a distance of 75 mm from the boundary is 1.125 millimeter per second. The fluid has absolute viscosity 0.048 Pascal second and relative density 0.913. What is the velocity gradient and shear stress at the boundary assuming the linear velocity distribution? So we can see from this question, we have many parameters that we have studied earlier, like velocity, the velocity given in meter per second, then we have a distance 75 mm. So normally if it's not in SI unit, so we need to convert it to SI unit. So for distance, SI unit is meter. Yeah, then we have absolute viscosity, then we have relative density. So all these names we are familiar in the lecture earlier. Okay, so the question is asking us to calculate. So it's saying what is the velocity gradient. I think this term also we have studied earlier. And shear stress. The shear stress is tau. Okay, at the boundary assuming the linear velocity distribution. So we know absolute viscosity mu is 0.048 Pascal per second. Okay, so try to extract whatever information given in the question. Okay, then we know this is the relative density 0.913. Okay, so the question first is asking to find the velocity gradient. Velocity gradient we know this is du over dy. Okay, so du, so velocity changes, so 1.125 meter per second, and also the distance is 0.075. So we know the changes is 15 per second. Okay, so this is for the velocity gradient. Then they ask to calculate the shear stress. So shear stress is tau. Tau equals to mu over dy. So du over dy we already calculated. So we already calculated 15 per second, and we know the value of mu. Okay, so based on that, we can calculate the shear stress, so which is 0.048 Pascal per second times with 15 seconds. So per second, so you can cancel. So the balance is 0.725. And the value is Pascal because it's a stress. So stress is similar like our force, okay, or pressure. Sorry, pressure. Okay, so that's for the first question. So the second question, so we can see for parallel plate arrangement of the type shown above, it is found that when the distance between plate is 2 mm, okay, again given in mm, we need to convert to meter. The shearing stress equals to shear stress, okay, of 150 Pascal developed at the upper plate when it is pulled at the velocity of 1 meter per second. So determine the viscosity of the fluid between the plates. Okay, so they're asking to calculate the viscosity. So we can see, so tau equals to mu over du over dy. Okay, so we know this. Okay, in order to calculate du over dy, so we have seen some of the formulas given to calculate the velocity gradient is v over d. Okay, so velocity over d. So you rearrange in order to find. So you mix mix this with this, then you rearrange, you can get mu equals to tau over du over dy. So you replace here, so we can get tau over v over d. Okay, so replace all the values that you given, so convert it to SI unit. So like 2 mm convert to 0.002 meters, 1 meter per second, and 150 Newton per meter square. Okay, so you solve it, you will get some mu equals to 0.3 Newton second per meter square. Okay, so that's for the second question. Okay, for the third example, the flat plate 0.1 meter square area. Okay, so area is 0.1 meter square. Is pulled at 30 cm per second. So convert to meter per second. So relative to another plate located at a distance of 0.01. So the separation is 0.01 centimeter from it. The fluid separating them being water with. Okay, so the fluid in between is water. So mu is 0.001 Newton second per meter square. So they're asking to find the force and power required to maintain the velocity. Okay. So the solution we can see. So du. So changes of velocity is 0.3 meter per second. The changes of the distance is 0.0001 meter. Okay, so the separation. Okay, then so du over dy equals to 0.3 over 0.0001. So du over dy is 3000 per second. Then we can calculate from the formula for shear stress, tau equals to mu du over dy. So just replace the values. Okay, mu is 0.01, 0.001 times with du over dy calculated 3000 per second. Okay, then the shear stress is 3 Newton per meter square. It depends on if they never mention. So any unit that they want you to find, so you can give in any unit related to shear stress. Okay, then there are in order to calculate the shear force. So initially I said, so we have shear rate, we have shear stress, and we have shear force. So depends on what the question is asking. So we need to answer. Okay, so shear force, the formula is force equals to tau A. Okay, F equals to ma. So we just replace the force with the shear stress. Okay, so shear stress we already calculated, and area is given 0.1 meter square. So we can get the shear force is 0.3 Newton. And power. So power for fluid, power formula is power equals to Fv. So force times velocity. Okay, so since here is given the velocity is 0.3 meter per second. So force is calculated 0.3. So just 0.3 times 0.3. So you get 0.09 Newton meter per second. So 0.09. So this Newton meter per second for power is actually watt. Okay, so your power always will be measured in watt. Okay, so you can just write it 0.09 watt or 0.09 Newton meter per second. Okay, so the final example, the 25 millimeter diameter shaft is pulled through a cylinder bearing as shown in below. The lubricant that fills the 0.3 millimeter gap, okay, in between the 0.3 millimeter gap between the shaft and bearing. Shaft and bearing, okay, is an oil having a kinematic velocity. Okay, for this they have given the kinematic velocity, viscosity. So we have heard about this term earlier. So please refer. Okay, so what is kinematic viscosity? Okay, and specific gravity. I think this term also we have heard. Yeah. So we know it's a dimensionless, so no unit, 0.91. Okay, so determine the force P required to pull a shaft at a velocity of 3 meter per second. Okay, so they are given the velocity 3 meter per second. They asked to calculate the force P. Okay, so P here is not pressure, so it's force because it's mentioned here. Force is P. But normally in the question, we will give force equals to F, capital F. Okay, so they ask to assume the velocity distribution in the gap is linear. So meaning no acceleration. Yes, so we can see. So the resulting force equals to 0. Okay, because no force going out or in. Okay, it's just like converted. Okay, thus P or F equals to tau A. Okay, we know the formula for force, shear force is tau A. So A we know for cylinder, so pi d L. So pi d times with the length of the bearing or shaft. Okay, and tau is mu velocity over gap, mu v over d. So for du over dy, so you can use whichever information given. So if the information of velocity and separation is given, you can use v over d. Okay, so depends. So we have a few parameters that we can use. Okay, so from here we know P equals to, so you just replace the values that you got into this formula, and we know mu P over d times with pi dl. So you just settle this, and we know from coefficient of kinematic viscosity mu equals to V, so kinematic viscosity times with rho oil. Okay, so oil, so is given specific viscosity. So you can see here rho water at 4 degrees Celsius. So is 0.91. Okay, so it's given. It's already given 0.91. Okay, from here, so we just need to find the rho of oil. So this is how you can use the kinematic viscosity to find the specific viscosity. Because once you use this formula, you can find the rho of oil. Because rho of water at 4 degrees Celsius is already known. Okay, it's equals to 1000 kilogram per meter cube. Okay, so you just times 0.91 times with 1000. Okay, so you can get the rho of oil. Okay, then finally you just replace. I think all the information you already got. So you just replace in the force formula. Okay, so mu is measured 8 times 10 to the power of -4. Then here you already know the rho of oil 0.91 times 10 to the power of 3. So 10 to the power of 3 because it's 1000 here. Okay, so 3. Okay, so 3. So I think it's the separation. Then sorry, velocity. Then you have a pi here. Okay, so d is 0.025 and length is 0.5. So divided by d, the small d, 0.0003. So finally the force is 286 Newton. Okay, so I think that's all for the example. So we couldn't discuss earlier. So I just want to do this video so that you can listen over and over. Okay, so thank you so much.